Hello Algebra 1 students, we are in week 4 of our function booklets, literal equations and sequences. We are in tier 2, lesson 4b, writing a rule for a sequence in sequence notation. So let's check off our booklet. Here we are in tier 2, lesson 4b, writing a rule for a sequence in sequence notation. So one of the things that I want to talk about here is what a recursive formula is. A recursive formula is a function rule that relates to each term of a sequence after the first term to the ones before it. So in other words, what it's saying is, here's our first term, whatever that term is, every term after that first term is related to the term right before it. That's kind of what a recursive sequence is saying. So the sequences that I already showed you, our two buddies here that are written again, these are recursive formulas. So when you're writing, when you want to write a rule in sequence notation, the first couple things you want to do is you want to let n equal the number in the sequence, or the term in the sequence, and then let a of n equal the value of the nth term of that sequence. And that's true for both of these. So you can just fill these both out simultaneously. So what does all that mean? Well, let's look back at tier 2 4a here. So, and let's extract, we're going to extract this bad boy right here, a of 2. So we're going to bring that down here. So if we have a of 2 equals a of 1 plus 3. I'm going to shrink it. So how can we write this in terms of n like we have going on right here? Well, we don't know what the nth term is, so we need to know what a of n is. We don't know what it is. It might be the 187th term, the 984th term. We don't know. So some term n is going to equal whatever that term is. Well, look at this. So we have 2 here. If 2's here, what's the difference between 2 and 1? You have to subtract 1. Well, let's go to see here and check out lesson A, 4a. 3, subtract 1, yep, get 2. 4, subtract 1, get 3. 5, subtract 1, get 4. And then 6, subtract 1, get 5. Yep, so that all works. So here, it's going to be whatever number we decide to throw in here, whatever term, it's going to be that term minus 1, whatever that thing is, and then plus, what was our plus? 3. That'll stay. I'm going to shrink that too. So what this means is, if we wanted to write a rule in sequence notation with a function rule, aka recursive formula, we could do it in this format right here, okay? And that gives us the recursive rule or the function formula, however you want to look at it. And you could pick any arbitrary term of this sequence right here. So we could pick, let's pick term 7. So term 7 would be a of 7 equals a of 7 minus 1 plus 3, which gives us a of 6 plus 3, which works out exactly how we want. Now, it works the same over here. You can do the same thing, and we can come up here and grab a of 2 again, right here, and we see that it's a of 2 has a 1 here, a of 3 has a 2 here, a of 4 has a 3 here, so it's again going to be n minus 1 in that bracket, but now we're just going to have times 2. So to write the recursive formula over here, instead of a of 2 equals a of 1 times 2, what would happen is we're going to have a of n equals a of n minus 1 times 2. And again, if we wanted to pick like a of the 97th term, we would get a of 97 minus 1 times 2. So we would know that we have to take the 96th term and multiply it by 2 to get a of 97. Good luck on your practice sets.